Well, howdy. My name's Chris Wahl. We're going to talk about NFS and vSphere and why I think they're snazzy together. So a little bit about who I am, a couple things. One, I'm a VMware Certified Design Expert, VCDX number 104 in data center and network virtualization. So huzzah there. I write about a bunch of techie, labby, certification-y video type stuff. That's on wallnetwork.com. And you can also check out my courses on Pluralsight. That's pluralsight.com if you want to learn about the Cisco Certified Network Associate for Data Center or vCloud courses. You can go there. And I also do a podcast that's quite funny and focused on users called VooPass. And then finally, I do have a book that apparently the slide is a little goofy here. It's that darn 4x3. It's called Networking for VMware Administrators. It's available in just about every format you can imagine, and 100% of my profits are going to Alzheimer's Association. So if you buy the book, you can feel good and you can learn some stuff about networking. So let's get on. Okay, so we're going to talk about IP storage networks, specifically NFS here, but kind of generically IP storage as an entity. And what could possibly go wrong, right? You connect it and it works, and storage is mounted, and all is good. And the fact of the matter is the virtualization hypervisor is quite good at masking mistakes, and things that you may think are working properly may not be. So we'll go over a couple of those theories. The first is, let's build an IP storage network. And so in this particular use case, I have a network 30.30.30.0. That's not an actual IP address that you'd probably want to use. That's a public address, but let's just pretend it is. So that's my subnet, is the 30.30.30. So most likely the first thing I want to do is build out a port group. And I've got 2 VM NICs because, hey, you should always have 2 of something. Single points of failure are sad panda. So we've got port group, it's active, both uplinks are active. VM NIC 1, VM NIC 2 are there. We build out a VM kernel interface. It just randomly gets chosen to be VMK number 1, and we give that an address on that 30.30.30 network. So in fact, it's .50. So then we think, all right, everything's great, right? I've got 2 paths to storage. I'm using them both because it's active. It's all gravy. Maybe I've got a pair of 1 gig or 10 gig networks or interfaces going to my network. You may think, great, I'm getting 2 or 20 gigs worth of bandwidth out of this. In actuality, no, the sad pug is giving you the thumbs down. That's not what's going to happen. Because in reality, it's just going to pick one of these 2 interfaces, because the VM kernel interface can't live on any more than 1 active uplink at a time in this particular configuration. Now, if something were to happen to VM NIC 1 and it gets discarded because somebody unplugged the cable, or SpongeBob walked in there and he's quite large and square looking and he happens to hit the network cable, which happens, then it'll fail over to VM NIC 2. So you have the failover capabilities of those 2 interfaces. But the VM kernel can only write on 1 at a time. So it'll move over there, and then once you repair VM NIC number 1, it may go back or not, depending if you have failover turned on. So how do we get it to this particular state where we can use both interfaces at the same time? I want to use VM NIC 1 and VM NIC 2 simultaneously. Well, you might think, if you're a little creative with the network juices, you might think, I'll build a port channel using some kind of dynamic lag, link aggregation group like LACP, and now the interface lives on both of them logically. There's now 1 logical interface. And you may think, now my traffic will flow and things will be wonderful and both interfaces will be used. And in reality, no, still not going to happen. The interface still has to go through a hashing process where there's kind of a dice to get rolled, where basically we look at the source traffic, which is that VM kernel interface. We look at the destination where the traffic's going, which is your storage array, and we look at the uniqueness of those. And until something changes, we're going to keep picking the same path over and over and over again. So the hash algorithm is very reliant upon change. And if you look at it, if I have a host hypervisor and its interface talking to a storage array, a storage device at the other end, the MAC address, the IP address, the port, and the VLAN ID don't change. So until something actually changes in that environment, such as a re-IP the storage or whatever, it's not going to pick a new link. So you have to have, I don't know why I have Cookie Monster there. I like Cookie Monster, and quite frankly, it's my deck, so I put them in there. So you have to have some variation here. And if we look at this particular config, we've got .50 talking to .60. The IP, MAC, port, and VLAN ID don't ever change. So you'd have to reboot the host or something like that. So hash results, just pick 1 uplink. It may say, you know what, traffic's going to go down VM NIC 2 every time until some change is introduced in the environment. So even if you introduce a port channel or a lag, link aggregation group, to this config, it's still going to keep using 1 interface. And that may not be a big deal. You may have 10 gig networking for your NIC, and it doesn't really matter anyways, because it's quite rare these days. I'm sure 10 years from now we'll watch this and be like, oh, 10 gig, that's quite quaint. but in the reality of today's world, 10 gig saturation from a hypervisor to a storage array, pretty rare. It's going to be a corner case if you're saturating something like that. Now, if you want to use both VMNICs at the same time, you can actually present your storage array with a virtual IP. You can have multiple virtual IPs, and you can mount your NFS storage to those multiple virtual IPs, but you have to keep in mind my good friend SpongeBob and his magic rainbow that is the least significant bit. It's not magic, but it's quite ironic that it's the least significant bit. It's called that because it's the last bit on the end of the address. So if you were to distill that IP address from decimal to binary, it's that final 30-second binary bit that's on the end of the address. It's actually the most significant bit from my perspective because that's what's going to determine in an IP hashing scenario how I'm going to go either VMNIC 1 or VMNIC 2. So if you create multiple virtual interfaces on your storage array, make sure that last binary bit is different. It's easy if you have two uplinks. Make sure one is even, one's odd. And that way, one's going to be a 0 in binary, the other one's going to be a 1 in binary. And then when you mount the storage, you'll use both paths. Some generic tips that I'm going to give you, and I will include our friend iSCSI, which I'm not a huge fan of iSCSI for multiple reasons, but dedicate some VM kernel ports to NFS. Don't just use the management VM kernel, or don't just have one VM kernel interface for the whole host. That's bad mojo. You're basically sharing all sorts of traffic across one interface, and that creates a shared domain for any kind of fault. We also want to use a dedicated VLAN, typically one that has no routing. So avoid routing your NFS traffic if at all possible. So pick a VLAN, make it not routable, which means it has no routable gateway outside of the subnet, and there's no actual switch virtual interface for the VLAN. That way we have this isolated kind of secure and performance area. Nothing's really going in or out of this subnet. And if you're going to use something like iSCSI, which sometimes you just have to, use VM kernel port binding. It gets around all of the garbage that I just talked about. That's the end. If you want to catch me in any other format, I'm at Chris Wahl on the Twitters, Wahl Network, Pluralsight, or my YouTube channel. Thank you very much.